Solution of non-homogeneous differential equation. Solution of non-homogeneous differential equation. Obviously, non-homogeneous differential equation with linear differential equation with constant coefficient, which is non-homogeneous. We know that the general form of linear differential equation with constant coefficient is what? With constant coefficients is f(dy) is equal to qx. Either write small qx or this small qx or capital Qx. And this is the non-homogeneous differential. We know that if this qx is 0, then this is a homogeneous differential equation. That is the first topic of our syllabus, which is covered in the previous lectures. So the general solution of this non-homogeneous differential equation, suppose this is one. The general solution of non-homogeneous linear differential equation, this number 1, is the sum of two parts. Is the sum of two parts, namely the first one is what? Complementary function. Complementary function, that is denoted by, shortly denoted by CF or Y suffix C. And the another part is what? And the particular solution, particular integral, not solution, particular integral, shortly denoted by PI or Y suffix P, particular integral. So that is what? The general solution of one is what? Is y is equal to yc plus yp. This is the general solution of. So number 1, how we can find complementary function, that is this yc. The complementary function yc of equation 1, that is the given non-homogeneous differential equation, is the general solution of associated homogeneous differential equation. What is that? f(dy) is equal to 0. That is the general solution of this f(dy) is equal to 0. How we can obtain this associated homogeneous differential equation? Just replace in the place of qx 0. We have the associated homogeneous differential equation. Suppose this is number 2, and the general solution of this equation 2 is the complementary solution of this equation number 1. That is, the first part is what? Is the complementary function, and which is the general solution of this equation f(dy) is equal to 0, homogeneous differential equation. And how you can find this general solution of this equation? We can find the general solution of this equation 2 by using the previous topic. That is, there are 4 types to find the solution of this homogeneous differential equation. That depends on the roots of the auxiliary equation. That is the non-repeated real roots, repeated real roots, non-repeated imaginary roots, and repeated imaginary roots. That is, just write the general solution of this equation, but denote it is by using yc, y suffix c, okay, which is the complementary function of equation 1. So, and the particular integral. To find the particular integral yp, we use the formula. This yp is equal to 1 by fd qx. Okay, so this is the formula to find the complementary, to find the particular integral. So there are 6 methods. Write note. There are 6 methods to find yp, that is 1 by fd qx. Particular integral. To find particular integral depends on the nature of qx. These methods depend on the nature of qx. So what are that 6 methods? The 6 methods are: the first one is this qx, right? Either capital Qx or small qx. Qx, small qx, suppose here this qx is what? Either capital Qx or small qx. So this qx is what? Either small or capital. So the 6 methods are what? Qx is any function, general type. This is the general type. The second is qx is e raised to x. If qx is of this type, e raised to x. The third one is qx is x raised to m, or polynomial in x. So what is the polynomial in x? For example, this is the polynomial 3x square minus 4x plus 2. This is the one of the polynomial in x. So this is the second type, that is third type, that is qx is of this type, x raised to m or polynomial in x. The fourth type is qx is xv. What is v? Where v is any function of x. The fifth type is qx is sin x or cos x. And the sixth type is qx is e raised to xv. What is v? Again, where v is any function of x. So there are 6 methods to find particular integral of non-homogeneous differential equation. So we'll start the method number first. First method, that is called general method. That is qx is what? In this qx is what? Qx is general. The qx is any function of x. So we start with one theorem or question. Example, prove that 1 by d minus a qx is equal to e raised to x integration e raised to minus ax qx dx. We have to prove this result. So solution or proof. Let y is equal to 1 by d minus a qx. and therefore d minus ay is equal to qx. What is d? d means d by dx. So dy is what? dy by dx minus ay is equal to qx. And this is what? This is linear differential equation. This is linear differential equation of the form dy by dx plus pxy is equal to qx. What is px? Where this px is this minus a and qx is this small qx or capital Qx. Then in order to find the solution of this linear differential equation, first find integrating factor, generally denoted by I. And what is the formula to find integrating factor? In e raised to integration px dx. That is what? E raised to integration. What is px? Is minus a. So what is the integration of minus a? Minus a is constant, so its integration is minus ax. So this is integrating factor, e raised to minus ax. And then what is the general solution? General solution of this equation. Suppose this is equation star. So this is linear differential equation and its solution. General solution of equation star is what? Yi. This is the formula to find the solution of linear differential equation. What is the general formula? Yi is equal to integration I into qx dx plus constant of integration. So here we are going to find particular integral, and particular integral does not contains any arbitrary constant. So don't add this constant of integration without adding constant of it. Find integration without adding constant. So yi is equal to integration I into qx dx. So what is I? E raised to minus x. E raised to minus x, and qx is what? Qx is small qx. Okay, right? Capital Qx. That's depend on the notation. And then what is y? Shift this e raised to minus ax. It becomes e raised to ax. E raised to minus integration e raised to minus x qx dx. And what is y? What is y? Y is this 1 by d minus a qx. So write y as 1 by d minus a qx is equal to e raised to ax integration e raised to minus ax qx dx. So this is the rule to find 1 by d minus a qx. For example, what is 1 by d minus a q d minus 3? Suppose 3. What is d minus 3 qx? What is it? E raised to 3x integration e raised to minus 3x qx dx. But what is 1 by d plus 3 qx? So what is d plus 3? If you compare d plus 3 with d minus a, then a becomes what? A is minus 3, because you can write d minus 3 as d minus minus 3. How we can write d plus 3? D minus minus 3. That is, if you compare d minus a with this d minus minus 3, then a is what? A is minus 3. So write here a as minus 3. So what do we have? E raised to minus 3x integration e raised to minus, already this a is minus 3, so this becomes e raised to plus 3x qx dx. So this is by using this rule. If we have d minus 3 at this place, then write e raised to 3x e raised to integration e raised to minus 3x qx dx. But if I have d plus 3, then a becomes minus 3. So right here minus 3, here minus 3. So minus minus become plus 3x qx dx. So we'll find the solution of differential equation by this method. Example number 1. Question is solve the differential equation d square y by dx square plus 4 dy by dx minus 12 y is equal to g is equal to e raised to 2x. So solution, the given differential equation is what? D square y by dx square plus 4 dy by dx minus 12y is equal to e raised to 2x. That is d square y plus 4 dy minus 12y is equal to e raised to 2x. And that is d square plus 4d minus 12y is equal to e raised to 2x. And this is of the form fd y is equal to qx. What is fd? Where fd is d square plus 4d minus 12, and what is qx is e raised to 2x. Okay, and this is what? Suppose this is first, and this is what? Is non-homogeneous differential equation. So write the associated, the first part is what? Complementary function. For that, write the associated homogeneous differential equation is d square plus 4d minus 12y is equal to 0. So write, replace this qx, that is e raised to 2x by 0. So this is what is the associated homogeneous differential equation, and we'll find the general solution of this equation number 2. So that for that, write auxiliary equation. The auxiliary equation is what? The auxiliary equation is fm is equal to 0. That is replace m by d by m. So factorize this polynomial. So what are the factors? The factors are m plus 6 and m minus 2. That is multiplication of 6 and minus 2 is minus 12, and the addition of 6 and minus 2 is 4. And therefore m is minus 6 and plus 2. And therefore the complementary function is of 1. This is the complementary function of equation 1 is yc is equal to c1 e raised to minus 6x plus c2 e raised to 2x. What is the complementary function? This is the complementary function. Actually this is what? The general solution of equation 2. But this is what? Complementary. In order to write the general solution